All right, this video is going to be over the first lesson of our new probability unit, the counting principle and permutations. This probability unit sheet that you're looking at, this is a packet of all of the examples and notes. I passed this out in class. If you were not in class to get it, then it is a PDF is linked to the absent work calendar. Okay, you don't necessarily have to print off the entire packet right now, but you are going to want to print off pages 1 through 3. If you're unable to print, please reach out to Mrs. Shape. If you're going to be back in school maybe the next day, then you can get a paper copy in class. But if you know you're going to be out for several days, then make sure you get in touch with me and I will find a way to get you a paper copy. Of course, you could always just write all of this out on a piece of paper. Okay, so remember, whenever you're gone and you listen to these video notes, you get credit for watching this and making up what you missed. So please make sure when you come back, you show Mrs. Shape that you have all of the examples. All right, so what we're going to talk about today is what's called the fundamental counting principle. And this is mathematically what can be used to find the number of ways that an event can happen, okay? We talked about in class, suppose that you knew somebody's, or you wanted to figure out the number of possibilities of somebody's 4-digit PIN. And so we talked about how we could figure out how many PIN numbers exist. So that's, just one of the ways that you could use this. So what I'm going to have you do is I'm going to have you start by writing down the fundamental counting principle. So what the best thing to do is to hit the pause key, write it all out, and then hit play when you're ready, and we'll get to example 1 and use it. So what this principle says, if there is A ways to do one thing, and B ways to do another, and C ways to do a third, ... means and so on and so on, then the total number of ways the event could happen is, and what we're going to do is we're going to multiply A times B times C, and we're going to multiply all that together, and it'll tell us the number of possibilities. So like I said, hit the pause key, write this down, and when you're ready, let's take a look at example 1. All right, so for example 1, it says Happy Meals at McDonald's come with a choice of hamburger, cheeseburger, chicken nuggets, French fries, apple dippers, and then the drink would be white milk, chocolate milk, apple juice, or Sprite. And how many ways can a Happy Meal be ordered? Well, without using the fundamental counting principle, what we would have to do is we would have to list out all the different possibilities. We could say hamburgers, fries, and milk. We could say hamburgers, fries, and chocolate milk. Okay, and I want you to see that obviously this is going to take a long time, so we want to find a better way to do this. We'd have to say hamburgers, fries, and apple juice. And then finally we'd have to say hamburgers, I'm writing really messy here, fries, and then Sprite. Okay, so right away, that's just 4 different Happy Meals based on the 4 different drinks. Well, then we'd have to go through and say hamburger, apple dippers, milk. Obviously, we want to do this in a better way because we don't want to have to write out all of the choices. So what we do is we use the fundamental counting principle. Well, how many things do you order? You order 3 things. And what you're going to see as a common trend is that all these problems I'm going to solve by basically making blanks and figure out what number goes on the blank. So this is what I call, this would be like the main dish. Then we get a choice of side, and then we get a choice of drink. Well, how many different main dishes can we order? Hamburger, cheeseburger, chicken nuggets, that's 3 main dishes. 2 choices for a side and 4 choices for drink. So this principle says that if we multiply 3 times 2 times 4, that's going to give us 24, and that means there are 24 ways to order a Happy Meal. Which is sometimes maybe why when you go to McDonald's and you see people ordering and they're having trouble figuring out what they want to order, it's only because they have so many different choices. 24 ways to order a Happy Meal. So I think what you're going to see right off the bat is this is not a very difficult mathematical concept per se. It's more just kind of read it, problem solve it, figure out what we want to multiply. All right, let's look at something a little bit more complicated. So on a 12-question test, numbers 1 through 5 are true, false. 6 through 12 are multiple choice, and each of those have 4 choices each. If you know that numbers 3 and 8 are correct, but guess on all the others, in how many ways can you complete the test? All right, so Normally what happens after people read this is it just sounds like a really confusing problem. So it always comes back to how many blanks do we have? How many items are on this test? And the answer is 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I like to number the blanks so that I understand what they mean. This is question 1, 2, 3, 4, and so on. Okay, so continue with me here, labeling these questions, numbers 1 through 12. And let's even go more into this, more specific with our labeling. We know that 1 through 5 are going to be true, false. Well, how many choices do you have for true, false? And the answer is, well, you got 2. It's either true or false. And then it says that 6 through 12 are going to be multiple choice. Okay? You could have multiple choice with different options. You could have 4 choices, 5 choices, but they do tell us in this problem that each multiple choice has 4 choices. Now I find it interesting, this part where it says that numbers 3 and 8 are correct. How does that work? Okay, well, let's look specifically at number 3 and let's look at number 8. How many different ways could you answer number 3? So you know what, let me even back up. Number 1, you're purely guessing, right? So you're guessing. There's 2 ways you could guess. You either guess true or you guess false. Number 2, you're guessing. You either guess true or you guess false. Now number 3, you get it correct and you know it's correct. How many different ways can you answer a question correctly? There's only one way to answer that, right? And so then we continue on. 2 if you guess, 2 choices if you guess. Well, now we're switching to multiple choice. So if you just purely guess on a multiple choice, you could choose A, B, C, or D. So that's 4 choices. 4 choices for number 7. Now number 8 again, you get correct. How many ways can you answer something correctly? There's only one way to answer it. So these again are ones because we know that they are correct, while the others were guessing. So 4, 4, 4, 4. And what that fundamental counting principle says is that we multiply all of these together. Okay, so times 4 times 4. So when we go into our calculator, another part of this lesson is how can we type this in and just be a little bit quicker, be a little bit more savvy in the way that we're typing. So I need to take 2 times 2 times 2 times 2. So how we could write that is 2 to the 4th power. That's what exponents are. They're repeated multiplication. And then we're going to multiply that by, how many times are we multiplying the 4? 1, 2, 3, 4, 5, 6. So now I'm going to multiply that by 4 to the 6th power. All right, so go into your calculator. Hopefully you have one on deck ready to go. And we're going to type in, so I should have had this lined up here. All right, so I'm going to clear this out. We're going to type in 2 to the 4th power times 2 to the 6th, no, I'm sorry, nope, it was base 4, and that was going to be 4 to the 6th power. And this is a nice way to type it so you don't have to write it all out. And what we get is 65,536. So let's come back to over here. And so what we can say is there is 65,536 ways to answer this test. Well, if nothing else, I think that mathematically proves why we shouldn't guess on a test. Obviously, the more you study and the more you get correct, the less ways you have to answer a test. All right, so the next 2, we're gonna go over to page 2 here. Okay, and I just have 2 more examples for you. We'll come back to this right here, but there's 2 different types and 2 different buttons I want to show you in the calculator. Let's take a look at example 3, and then we'll circle back and talk about what's in that box. So 9 runners compete in the 100-meter dash. In how many ways can they finish the race? So again, on trend, like we've been doing all the other problems, this is not about picking up your calculator and typing something in. You have to show a thought process for all of these. So what we're going to do is, let's start with our blanks. Well, how many things are we placing into 1st, 2nd, 3rd, 4th, 5th? 9. So a runner could be 1st, 2nd, 3rd, 4th, 5th, 6th, 7th, 8th, 9th. Okay? So let's just kind of label that here. It helps me understand what number I'm going to put on the blank if I understand what those blanks mean. So these are the places in the race. Okay? Well, you can imagine all the runners, they line up, they hit, they start the race. Well, how many different runners out on the track could possibly be first? Well, any of the 9 runners could be first. Okay, let's say that a runner crosses the finish line and they're done. Well, now there's 8 people on the track who could be second. And then when 2 people finish, now there's 7 left. And I think you can see what I'm doing here is after everybody finishes the race, now there's only 4 people left who could be in 6th place, 3 people left, 2 people left, and finally, there's only 1 person who could possibly be in 9th place because they're last. You can use your calculator and type in 9 times 8, 8 times 7 times 6 times 5, and so on, okay? But what I want to tell you is this is actually a mathematical operation, and what this is called is 9 factorial. And it looks like an exclamation point. And that's what this first box right here is saying, is this symbol with the exclamation point is called a factorial, okay? But it's when you are arranging objects. It's when you're arranging 9 objects into first, second, third, fourth, all the way through the 9th place. So what that means when we see 5 factorial is it means 5 times 4 times 3 times 2 times 1, and you always build all the way down. So let me show you how to do this in your calculator. What you're going to do right here is you're going to hit the math key. See how it's highlighted in red right here? This math key is underneath the alpha key. All right, so find the math key. And then we're going to go over to this menu right here. I'm just using the arrows. We're going to go over to where it says probability. PRB stands for probability. And look right down here at number 4 is this exclamation point. I'm going to hit enter. You know what? I'm going to actually back up and we're going to do this again because I forgot to hit the 9. So let's hit 9 first. Let's go to the math key again and over to probability. Now from here, you could actually just hit number 4. You don't have to scroll down, but I'm going to go down to number 4. I'm going to hit enter, and I see this 9 exclamation point. Okay, and that is the total number of ways that the runners could finish the race. 362,880. So let's come back over here, and this is equal to 362,880 different ways that these runners can finish the race. All right, so last problem that we're going to talk about. What if we still keep this theme of a race, but instead of placing all of the runners, which by the way has just now become 19 runners, we're only going to place the first, second, third, fourth, and fifth places. Okay, so this time we just want to know in how many ways can 19 runners be placed in first, second, third, fourth, and fifth place. Well, very similar to before, any of the 19 runners could possibly be first. Well, then you would have 18 remaining runners who could be 7, and 17 could be third, 16, and finally there would be only 14 runners that could possibly finish fifth. And we're going to stop there because we're not trying to place 6th, 7th, 8th. We're stopping at 5th place. So this is not a tough thing to type into your calculator, okay? You could very easily type in 19 times 18 times 17 and so on. But this again is a mathematical calculation that I want to teach you, and this is what's called a permutation. All of these are permutations that we're doing. All we're doing is taking a number of objects and placing them in order. Okay, so what we can do though is we don't want to use 19 factorial because 19 factorial would be 19 times 18 times 17 times 16 all the way down to 1. That's not what we're doing here. So what we're going to do is we're going to take 19 things and we're going to place 5 of them. And that P stands for permutation, but I always think of it as placing, because that's what permutations are, is it places objects. So 19P5 means 19 things to start with, and you're placing 5 of them. And again, we can do this in our calculator. If we type in the 19 first, hit that math key again, go over using your arrow to probability, and what you're going to see is number 2 is NPR. And that's what we want. So pull out NPR, hit enter for number 2. And so it's 19, and then we put the 5. So your calculator is plugging the 19 in for the first, and it's going to plug 5 into here, and we hit enter. And just like that, that is the same calculation as if we were to multiply this out by hand. So 1395360. Let's write this as our answer. Sorry about that. All right. So what we would say here is 1395360. So what is this? 1,395,360 ways that 19 runners could finish in first, second, third, fourth, and fifth place. Okay? Which is why it makes it tough to predict how a race is going to finish before it starts, because there's so many different ways that that race could finish. So what I'm going to have you do now, and that's it for the examples. If you look at page 3 in this packet, what you're going to see is this little on your own, okay, for the examples. So I want you to work through these. You've got the answered scrambled here at the bottom that you can then work through a problem. And again, what I want to see on every single problem is I want to see, I don't want to just see the answer, but I want to see you work out with the blanks, right? And so, and we can even kind of talk about number 1, but I want to see the work for it. I want you to see you to write out the blanks and put the numbers that you're multiplying by and then put the answer, check it at the bottom, and you can shade it out. And obviously you can come back with questions, but at least this gets you started on catching up on what you missed. Okay? So let's talk about number 1. If you're good, just go ahead and stop the video, but let's talk about number 1 so that nobody starts this and says, I don't know what to do, I can't do it. All right. Harry is selecting new uniforms for his team. And pants come in 4 styles, shirts in 6 styles, and hats in 2 styles. How many different ways can a 3-piece uniform be selected? Well, that right there, the uniform, okay, is going to be in 3 pieces. All right, so what we're going to do is we're going to make a blank for the pants. Oops, sorry about that. We've got pants. And what else? We've got shirts, and then we've got hats. And that's what the blanks are going to be. Well, how many choices are there for pants? And there are going to be 4 styles. And, accidentally erased, 4 styles. And then shirts comes in 6 styles, and hats come in 2 styles. And that's the whole idea of this, is making your blanks. Think about how many possible choices you have for each one. 4 times 6 times 2 is 48, and so we can say there are 48 different ways to style this uniform. We come down to the bottom, we see 48, we shade it out, and there you go. Okay, so good luck with this. Get in touch. Let me know if you have any questions. Thanks for listening. Bye.